Section 4.5, triangle congruence, ASA, AAS, and HL. So looking at a couple of more shortcuts to that definition of congruent triangles, kind of what is the bare minimum amount of information that we need. So starting with a kind of a similar idea to side angle side, we have angle side angle. We can look at an included side. All right, the included side is the common side of two consecutive angles. So the side between two angles. Line segment PQ is included because it's between angles P and Q. So we have angle side angle congruence. If you have two angles and then a side in between them. So if we look over here, is there a way to prove that these two triangles are congruent by angle side angle or angle angle side, which is another option we have if you have two angles and then an unincluded side. So as you go around the triangle, an angle, another angle, and then a side. All right, versus here, the side comes between the angles. Here, the side is outside of the angles. So if we look here, can we use either of those? So we have a pair of congruent angles here with two arc marks. Ha! I got it right this time. We have a pair of congruent angles here with one arc mark. And then we do have a side that's shared. So that's some reflexive property right there. So yes, we can use angle, angle, side because we have an angle, and a side. Two arcs, one arc, and a tick. Two arcs, one arc, and a tick. Down here we have a set of parallel segments, okay? Well, parallel segments, we have a transversal NL, we get kind of that Z pattern with it, so we can get a pair of congruent angles. NL is common between both triangles. Now we only have one pair of congruent segments. Sorry, we only have one pair of parallel segments, okay? One pair of parallel segments only gets us one pair of alternate interior angles. It doesn't get us this one and this one. We would need the two segments on the sides to be parallel to get this angle and this angle. So unfortunately, we only have one pair of angles. We only have one side. So no, that's not going to work. We do not have enough information for that specific diagram. And the last one that we have, the last shortcut we look at, is HL, hypotenuse leg. This is specific to right triangles, okay? So this doesn't get used too often. But if you have the hypotenuse and a leg of two right triangles congruent to each other, then that is enough to say those two triangles are congruent. So a hypotenuse, the longest segment, and then one pair of congruent legs. So in these two triangles, ABC and DCB, we have the hypotenuse is congruent. Those are the longest sides opposite the right angle. CB is congruent to itself. CB acts as a leg for both of those. So yes, we can use HL. So three new ideas, three new configurations. So you have 5 ways to show that triangles are congruent. Side, 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 angle, side, angle, side, angle, 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 side, and HL. And really a 6th way, if you want to get crazy with it, you have the definition of congruent triangles. If you just want to go full bore straight into it. You have those 5 options. You need to get one of those configurations. So on the next page in your notes, I believe there are 4 proofs. Just a lot of opportunities for you to practice, check my completed notes online, talk with a classmate, see if you can work through those.